Similarly to the way any equation is solved, an equation with radicals is solved by using the inverse property. In this case, the inverse of a radical is found by raising the radical to the like power. Therefore, the inverse of the square root is the square. Another example. Find x. Square both sides. Square root of x squared is simply x. 5 squared is 25. X equals 25. Another example. Find x. Move -5 to the right by adding 5 to both sides. Always isolate radical to the left before squaring. Square both sides. Divide by 3. X equals 108. Another example. Find x. Square both sides. Solve for x. Subtract 2x and add 5 to both sides. X equals 13. Another example. Find x. Square both sides. 3 times 3 equals 9. 5 times 5 equals 25. Distribute. Add 25x and 36 to both sides. Divide. X equals 5.47. Another example. Find x. Square both sides. Subtract 9 from both sides. Divide equation by common factor 3 to reduce to x squared plus 8x minus 9 equals 0. Equation is now factored. Which two integers give a product of -9 and a difference of +8? Only two possible multiplications yield a 9. 9 times 1 and 3 times 3. And only 9 minus 1 equals 8 fits the middle term. So the factors are x plus 9 times x minus 1 equals 0. X has two values. X plus 9 equals 0. X minus 1 equals 0. X equals -9. X equals 1. Both -9 and 1 solve the equation. Now, some equations with radicals yield no value and, therefore, cannot be solved. For example, the square root of x equals -8 is telling you that the root is negative. Remember, negative roots do not exist. This example is the reverse of the last one. Same outcome. Negative roots do not exist. In this one, the square root of 3x minus 5 equals the square root of 3x plus 8. The equation gets cancelled, leaving an empty answer. All three equations shown will have either negative roots, which do not exist, or equations that cancel and cannot be done.